Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 9. This is Section 13.4. This is problem number 9. It says, draw the graph of the following function. Be sure to label the x and y coordinates of any critical points. So our function is f of x equals 7x to the third, or we would say 7x cubed. So it's a 7-step process to draw the graph. So step 1 is find the first derivative. So we're going to go f prime of x equals 21x squared. Now again, where that 21x squared comes from, the exponent of 3 comes down times the number in front of 7. 3 times 7 is the 21. And the exponent gets reduced by 1. The third power drops down to a second power. So the step 1, the answer is f prime of x equals 21x squared. Step 2, take that answer, set it equal to 0. 21x squared equals 0. Step 3, solve for x. So if I divide away the 21, x squared equals 0 over 21, or 0, but I want x, not x squared, so I can go square root on both sides. And you get x equals, technically it's plus or minus 0, which doesn't make sense for 0, so we just say x equals 0. So I got a critical value with an x-coordinate of 0, but how far up or down is it? So to find the height, the y value that goes with this x of 0, put my answer for x back into f of x. So f of 0 becomes 7 times 0 cubed. So 0 cubed, 0 times 0 times 0 is 0 times the 7 in front. The y-coordinate is 0. So I have a critical point at 0, 0. The x value is 0, the y value is 0, which is right there, 0, 0. Now, what type of critical value is this? Does my graph come down, 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 flatten out, and go back up? Or is it coming up, 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 flatten out, and go back down? So to find out, find the y value a little to the left, so I'll go to -1, and the y value a little to the right, I'll go to +1. So let's put in an x value of -1, find the y that goes with it. So f of -1 equals -1, let's keep the 7 in front, 7 times x cubed is 7 times -1 to the third. So -1 to the third, -1 times -1 times -1 is -1. Again, an odd number of negatives times the 7 in front. -7. So if I go back 1, I go down, so that's 5, say down somewhere around there, 6, 7. So let's put in a +1 and see if it's down the same height. And actually, you'll find out it's not. F of +1 is 7 times +1 cubed. So +1 cubed, 1 times 1 times 1 is 1 times the 7 in front is +7. So if I go over 1, I come out 7. So that seems kind of odd. One's above, one's below. So with a graph like this, which is typical of a function with a cube, what's happening is you're going to come up, 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 flatten out briefly, and then continue up. So one end, the left end, goes down forever, and the right end goes up forever. And it flattens out briefly as it comes through the point 0, 0.